Hi everyone, I am Gautam. I am physics faculty. Now I am going to discuss about applications on Young's modulus. This is our target. Now what are these applications related to Young's modulus means? Basically, in our last video, I discussed about y is equal to FL by AE formula. Young's modulus is actually what I told, longitudinal stress by longitudinal strain, that is F by A by E by L. From that information, we notice that the formula is y is equal to FL by AE. Now here what we did, we attached a load here for the wire. That wire mass is negligible, and here I am taking some load, and load mass is m. So load mass is m. What is the weight of that one? Mg. So here the force experienced by the wire is, that is nothing but load, is mg. And cross sectional area of the wire I can write as what? Pi r square. So now my formula is y is equal to mgl by pi r square. What I did, in the place of f, I substituted mg. In the place of a, I substituted pi r square. So when I substituted like that, I noticed the formula finally y equal to mgl by pi r square e. So Young's modulus is FL by AE, F equal to mg, A equal to pi r square, y equal to mgl by pi r square. This is the first one basic application. Let us see next one. Now we'll see the concept of when a wire is stretched or elongated, what is going to happen. Wire is stretched or elongate, what is going to happen. So during stretch or elongate, the wire nature of material will not change. Nature of material will not change. That means Young's modulus is same, because y indicates Young's modulus. Actual formula what we have, y equal to FL by AE. Here y is Young's modulus, F is force, L is length, A is cross sectional area, E is elongation. Now here when you stretch or elongate, nature of material of wire does not change. As nature of material of wire does not change, what will happen here? Young's modulus will remain same. So we can also tell one more thing is density. Density of wire also will not change if we stretch or elongate. So whenever they use the term stretch or elongate, immediately we can tell y is same, y means Young's modulus same, d means density, density is same. And also one more quantity called volume. When you stretch or elongate, volume of wire will remain constant. Area of cross sectional area will change, length will change. If you stretch wire, what will happen? Suppose this is the wire we have. If you stretch wire, it is becoming thin and long. Thin and long means what will happen? The radius has been decreased. That is, cross sectional area has been decreased and length has been increased. So when you stretch a wire, the radius decreases, length increases. That means there is change in radius and length. But the total volume if you observe, cross sectional area into length will remain constant. That is, during stretching, this is the information you have to remember. What are the points to be noted during stretching? The first point, Young's modulus is same. And second point, density is same. Third point, volume of wire will remain constant during stretching. Even cross sectional area and length will change. Total volume will remain constant. These three quantities you have to remember. Suppose in case they told same load. Suppose they told anytime same load. Immediately you have to fix that force is same. That means the wire is there. So we have taken one wire. For one wire we are applying the load. Load is nothing but here what? Force applied on the wire. That is only called as load. So when we are attaching the same load always, means force is said to be same. Same load is applied means force is said to be same. I hope you got idea about this one now. Let us see the next one now. Here we are going to discuss about the stretching case only. That's a wire stretched case only. That's actually what is the formula? Y equal to FL by AE. Here we are taking wire stretched means no doubt Young's modulus same. And if we even apply the same load, suppose we are applying same load, then F is same. If Y and F are constants, Y is constant, F is constant. Observe here, Y is constant, F is constant. These two things are constant means happily we can say that E, L and A relation can be given as E is proportional to L by A. E comes here, so E is proportional to L by A. L is length of the wire, A is cross-sectional area. So when we can write this formula Y equal to FL by AE as E is proportional to L by A, when we can convert if Y and F are constant, when F will be constant, same load applied. When Y will be constant, same material of wire is taken, Y will remain constant. So we can write E is proportional to L by A. E is proportional to L by A. That is the formula what we have to write. I hope you got idea how we got E is proportional to L by A. Now, let us see here. Now, what I am doing means, actually just now we told E is proportional to L by A. E is proportional to L by A. So, for this E is proportional to L by A, in numerator and denominator I am multiplying with L. Observe here, numerator and denominator what I am multiplying? L, L. So if I multiply that, what will happen? Because if you multiply numerator and denominator L, we can cancel these two things. So E is proportional to L by A only will left. So for that purpose, what I did here, L I multiplied. So but L into L, what is L into L? L square. What is A into L? Cross-sectional area into length of the wire means volume. So A into L will give us volume. L into L will give us L square. So here from that formula area into length as volume we wrote. So I am writing here volume V. Observe carefully here, area into length volume. L into L, L square. So E is proportional to L square by V. But I told you that same material. What happens when we take the same material? Yes, same material if you are taking, volume will remain same. Or volume will remain constant. That is same material stretch. That means whenever you stretch the material, what will happen? Volume will remain constant. Stretching. That is actually we have to say stretching concept. And during stretching, volume will remain constant. So now what happened here? Stretching volume will remain constant. Previously we wrote E is proportional to L square by Y. Now what happened means in this formula volume will remain constant. So when volume is remain constant in this formula, what I can write? E is proportional to L square. E is proportional to L square. As E is proportional to L square, now we can write E1 by E2 is equal to L1 square by L2 square. So this is my final formula. E1 by E2 equal to L1 square by L2 square. I hope now you are clear with this one. So when we can write E is proportional to L square during stretching of a wire. During stretching of a wire, whenever they told stretching, relation between elongation and length means don't write E is proportional to L. Generally what the people will be thinking, E is proportional to L by A is there, no. So E and L means E is proportional to L. It is wrong. E is not proportional to L. E is proportional to what we can write? L square. Whenever wire is stretched, These all situations we are discussing during stretching. When we are discussing during stretching, E is proportional to L square. I hope you got idea about this one now. Let us see the next one. So here E is proportional to L by A is there. In numerator and denominator, I am multiplying with cross-sectional area. In previous case we observed, I think, we multiplied with length. Now what happened? We are multiplying in the numerator and denominator cross-sectional area. So what will happen? Here in the denominator, happily you can observe what is there in the denominator here. Here also we have A, here also we have A. A into A square. length into area, volume, because volume is nothing but length into area. So that volume, anyhow we know that during stretching volume constant, already we told during stretching volume constant, because in the numerator area into length became volume. Again that volume is constant during stretching. So whenever you stretch, volume is constant. So that this is constant means how E and A square are related. E is proportional to 1 by A square. E is proportional to 1 by A square. So elongation cross sectional area are related like that. We can write now E1 by E2 is equal to A2 square by A1 square. This is the given formula for us. What we did, I think you understood, is proportional to L by A and A, numerator A, denominator A. Area into length, volume. So volume is constant, E is proportional to 1 by A square. E is proportional to 1 by A square means E1 by E2 equal to A2 square by A1 square. Very simple. You have to remember during stretching, volume is same. Next one. So I hope you are clear till here now. What the next one means here, E is proportional to 1 by A square. Okay, we know that E is proportional to 1 by A square. But what is A? Cross-sectional area can be written as pi r square. Because cross-sectional area means, suppose I have taken this cylinder like that, wire, this is cross-sectional area. The radius is r. A is A. Cross-sectional area is A. So, area equal to pi r square. Anyhow, you know that pi is constant. Pi is constant. As pi is constant value, so I can write A is proportional to r square. So how area, cross sectional and radius are related? A is proportional to r square. Already we wrote here E is proportional to 1 by A square. Here we wrote A is proportional to r square. So now this A value, what I am doing, proportional to r square, now I am going to put now here. So in the place of A, what I did here? R square. Again whole square, because only A is r square whole square. So I will get finally E is proportional to 1 by r power 4. E is proportional to 1 by r power 4. So from this formula happily you can say E1 by E2 is equal to R2 power 4 by R1 power 4. Reciprocal. So here E1 is there, here we get R2. E1 by E2 equal to R2 power 4 by R1 power 4. This is the formula. I hope you are clear with this one now. Okay, let us see next one. Here what I am doing means, suppose for example I have taken two wires. Both are same material. Let me suppose both are steel. This is also steel wire. This is also steel wire. Both are steel. But one length is L1, other length is L2. So mass will be different. Because lengths are different means mass will be different. How the elongation and length and mass are related? For the both the rods, I applied same load. For the both steel wires, I applied same load. Same load means force is constant. Both are steel. Both are steel means same material. So same load, same material. Already you know what will happen when same load, same material is taken. Already I told you long back, same material, same load if I have taken. Here see, observe, same load, same material. For the two wires are made of same material and they are applied same load. Then I can write E is proportional to L by A. E is proportional to L by A. From that information, now what I am doing here, just I have taken that expression now. See, here what it is that one? E is proportional to L by A is there. You can observe it clearly. E is proportional to L by A. Now, I multiply numerator denominator with LL. Already we did this one. So, we know that E is proportional to L square by V. E is proportional to L square by V. So, this is the expression we got. Now, what I am doing means, I am taking density. Here, what is D? Density. And numerator and denominator I multiplied with density. What will happen if I take density and multiply to the numerator and denominator? Numerator nothing will happen, but in denominator you observe volume into density. What is volume into density is called as mass. Volume into density is called as mass. So in the numerator no effect, but in the denominator volume into density is called as what? Mass. And in numerator we have density. But anyhow, see, when that we are taking same material means density same. I already told you that same material means what happens? Density same. Where did I told that? See here. Same stretch or elongated, whatever it may be. That is same material. Same material means Young's modulus same, density same. Now here also what happened? I am taking that density same. Density is constant. So density is constant means what happened? First step is proportional to L by A. Next multiply numerator denominator with L. We got L square by volume. After that multiply numerator denominator with density. So in the denominator volume in density is called as mass. Volume in density is called as mass. And in the numerator density anyhow it is constant. So I can write the expression is proportional to L square by M. So E1 by E2 is equal to L1 square by L2 square into M2 by M1. Like that we can derive this formula when we are comparing two wires of different lengths and masses but made up of same material. Remember, made up of same material and applied same load. Same material they are made up of, and also they are applied with the same load. Same load means same force. Same material means what we can say? Young's modulus same, and as well as density also same. Density also same. So if you want length, mass and elongation relation, you can follow this method. I hope you are clear with this one now. So we discussed few applications in this session. In next class we'll continue few more applications of Young's modulus. I hope you got idea. So what we did from starting onwards, once we'll see. First application, y equal to FL by AE. F is nothing but what? Mg. A is nothing but pi r square. Like that we did this first application. Second application, what we did here, that is y equal to FL by E, same load, and we are stretching or elongating. What are the constants and everything we noticed here. Then as same load and same material, E is proportional to L by A we got. Then multiply numerator denominator with length we multiplied. If you multiply length and length, what we got? L square by V. V is constant, so E is proportional to L square. Next what we did is proportional to L into A by A into A is proportional to volume by A square. Volume is constant, is proportional to 1 by A square. E1 by A equal to A2 square by A1 square. Next what we discussed here after this, here A is nothing but pi r square. Pi constant, A is proportional to r square. So in the place of A, r square. So r square whole square. E is proportional to 1 by r per 4. This expression we got. After that what we did is proportional to L by A. Numerator denominator L we multiply. So L square by volume. And again what happened? I have taken actually here what happened in this situation. Two different wires. One is length L1. Other one is length L2. But both are same material. Lengths are different but material is same. And here what happened? Both the things same load. Same load, same material. You must not forget. Same load, same material. Same load, same material. And if you do this application, finally we are getting E is proportional to L square by M. Very important. Okay, I hope you are clear with this class. Thank you.